Hello everyone, my name is Kevin and I'm the co-founder and CTO of Tecton. Thanks so much for joining today's webinar on the topic of AI-assisted feature engineering that leverages MCP, Cursor, and Tecton. I've been in the space of building machine learning applications for a little over a decade now. First, I was at Uber where I helped build the central machine learning platform team. And then over the last 7 years, I've been working super closely with a lot of enterprises and startups who were building real-time machine learning applications for things like fraud detection, insurance underwriting, and product recommendations for e-commerce websites. And over the last 7 years or so, it's gotten significantly easier to build machine learning applications that power real production use cases like fraud detection. However, it's still pretty hard. It's honestly still harder than it really needs to be. And I think that LLMs will actually make a really big difference going forward. Because one of the pretty proven by now killer applications of LLMs is AI-assisted software engineering. You see it everywhere with tools like GitHub Copilot or Cursor, or Windsurf, or Claude Code, or any of these tools that software engineers are now way more productive than ever before by leveraging these LLMs. And the exact same thing will certainly also affect the discipline of machine learning engineering, and that MLEs and data scientists are deeply involved in. And in the coming 30 or 45 minutes, I want to show you what this already can look like if you are leveraging Cursor together with MCP and Tecton. And first, I will walk you through a couple of demos of what it looks like to use Cursor with Tecton to help you automatically write and debug feature pipelines. And then I'm also going to share a couple details about the architecture and how the whole system is built. And then at the end, I also want to share a couple of the lessons I've learned using Cursor and MCP and Tecton to build this entire system. There were a couple surprises in there that I really did not expect when I first started this project several months ago. So with that, let's dive in. All right, here we are. We are in a Cursor IDE, which is already set up with Tecton. I will show in a little bit what the setup looks like. But before I bore you with the architectural details and the settings, etc., let's just actually show you what the system can do. And let's just ask Cursor what it knows about Tecton. And we're asking the agent in Cursor what Tecton tools it actually has at its disposal. I've selected the Gemini model, and the Gemini model is now thinking and taking a look at the different MCP tools I've made available. And it now tells me that it can query the Tecton SDK reference, can look at code examples, and can actually take a look at the entire SDK reference as well if it wants to. So let's see what we can learn from it. I'm just asking it now to use those tools to learn a little bit more about stream feature views and then tell me what I should know about it as a new user to Tecton. Excellent. And here it explains the different core concepts that are relevant to a stream feature view. Well, that's quite a lot. Let's just have it summarize it. Why does Tecton matter for streaming ML features? Oh, excellent. And basically, what does it tell us? Tecton is really good at unifying stream and batch data processing and will ensure that there is no online-offline skew, and we're really good at time-weight aggregations. All that is accurate. Perfect. Now let's actually have it build a feature for us. And I'm going to ask it to take a look at a data source that I've already onboarded and propose a feature that it may want to implement. Now Gemini is analyzing this data source, specifically the Snowflake data source that has a bunch of device session IDs and whatnot that are implemented. And I now want Cursor's help in telling me, hey, what types of features may be useful for a fraud detection use case? And now it's proposing a couple different ones. And which one do we want to pick with? Let's go with average user. Let's go with device user count. Let's now ask it to actually build a feature for us. And it'll create a plan of what this could look like. And what you'll see in a second is that it will analyze the existing repo, add new entities if necessary that it uses to do feature engineering around. And now it'll go ahead and actually create the first feature definition for me. Perfect. So it created one pretty quickly, but this will likely not be enough, because what's super important with LLM assisted engineering is these systems are non-deterministic. So you need a way to almost formally verify that the result is correct. And with Tecton, there are a couple of ways to do that. One is our CLI Tecton plan validates that the implementation is not just from a Python perspective syntactically correct, but they're also following that they're using the different parameters and whatnot correctly. So let's actually ask it, hey, how can you validate that what you've created is correct? And here we see the stream of consciousness, the thinking output of this Gemini model. Perfect. It knows that it can use Tecton plan to run a static validation, and then it can run some manual validation, etc. But I really care about it running Tecton plan. So now I'm asking it to just run Tecton plan and validate that its implementation is correct. And you can think about this almost like a compiler step to see if it's that tells it whether it's actually implemented something correctly or not. And as you can see, it made a mistake. Like, it thought that the join keys parameter is just a list of strings, but actually it needs to be those strings that refer to column names need to be enveloped in this field class. And what you'll now see is that it's now running through this validation loop several times, and it will always look at any error message that is coming out to and then we'll attempt to fix it until eventually Tecton plan will succeed. Here we see that it's trying to use the approx count distinct function, but it's not setting the precision parameter correctly. And what it's now doing, which is quite interesting, is it's calling this MCP tool from Tecton, where it tries to get a sense of, okay, what does this function actually expect? What parameters do I need to set? How can I set the precision? And then the MCP tool returns the SDK reference details. And as we can now see, the LLM was able to now properly use this approx count distinct function. And instead of just referencing it using a string, it references it using this function. And voila. With this, we now have a batch feature view implemented. I didn't have to write a single thing myself. It was all the agent's work, and it has validated that this feature view is at least statically correct using Tecton plan. All right, let's do one more thing now, and let's actually use Tecton to create a stream feature view for us. But first, let's ask it to look at the SDK reference and build an understanding for it. We should now see that it's going to invoke the MCP tools again, where it will look for sample code snippets of existing stream feature views, and it will query the SDK reference, then build an understanding of how it needs to best use the Tecton SDK to implement these features. And similar to before, I'm now asking it to create a new feature, but this time a streaming feature, which leverages the transactions stream data source that I've already implemented. And it's now looking at some cursor rules that I've defined that give it a bit more information about, and really system prompting about how to best use Tecton to build features. Now it's asking me what type of feature may I want to implement. Let's go with the average transaction amount. Now it's again thinking, how can it best implement this feature? And it's asking me, how often do we want to actually refresh this feature? Let's go, or rather what time window we want to use. Let's go with 15 minutes, please. Okay, now it's come up with a plan. And this is again its first shot implementation. And this time, now that it's looked at the cursor rules, it's running Tecton plan automatically to just validate that this is actually working properly. And of course, it made a mistake because it just hallucinates a little bit and makes up some parameter names and whatnot, and hallucinates where certain classes could be imported from. And now it's just, again, going through this loop and one after another fixing these different issues. And we can just watch in real time what it's doing, how the code is changing, what errors it has made, and eventually we should see that a Tecton plan will pass. Specifically, what we see now here is that it had to set the stream processing mode parameter to continuous, and this is really an indicator that tells Tecton, hey, this is a continuous streaming feature, one that's continuously updated, and where we care about freshness in the millisecond or second range. Excellent. So it's built this feature. Now, next step is let's actually ask it to build a unit test for us. Let's come up with its plan again. It looked at the rules and the cursor rules that I've defined in here that tell Cursor how to best use Tecton and how to build unit tests with Tecton. And after a couple seconds, it has come up with its first shot implementation of what this unit test should look like. And now it'll run Tecton test to see if this test actually passes. And of course, it doesn't immediately pass because it's dreaming up, it's hallucinating how somewhat how to really invoke this unit tests. And for instance here, it didn't quite get it right how to pass mocked streaming data into the function that actually invokes the feature view. So it's fixed that, and now it's run into some other issue where it seems like it misunderstood what the outputted feature name is. So it's fixing that. And similar to the previous case, it's now going in this loop, looking at every single validation error of this unit test, and will fix whatever issues it has. There's another very common one where the expectation and the actual values use slightly different precision and time zones in their date time format. Okay, great. And it's almost there. Now it's interesting. We can see that the expectation it has streamed up doesn't entirely match what Tecton is calculating. So let's now see why that is. Why does the expectation of this thinking model not quite match what Tecton is doing? And it seems, and it's pretty smart how it realizes here that the subtle differences come in how the LLM thinks events on the window boundary are handled versus Tecton. And that's typically one of those things where different systems apply different logic to whether events on the event boundary or time span boundary are treated exclusively of the time bounds or inclusively. And perfect. Now it was able to adjust the test case and actually run the test successfully. Wonderful. And now finally I'd like to walk you through high level just how this integration with Cursor is actually built behind the scenes and some lessons that I've learned building the system. One of the most important things that we're using in the system is MCP. Anthropic created the standard. For those of you who haven't heard about it yet, it's basically a standardized protocol of how you can define tools that you can give LLMs access to. And tools are really ways for an LLM to take action, like sending out an email, or a way to request additional context, additional real-time context that may be relevant to solve the problem at hand. And in the case of Tecton feature engineering, very relevant context is, well, what does the SDK reference look like? Or what do other code examples look like? This is high level the architecture of how it's all stitched together. You see Cursor as the MCP client on the left-hand side. And we've got a bunch of different Cursor rules defined. Those are really system prompts that give the LLM a bit more information about how to use Tecton, what it's all about. Then we connect it to this Tecton MCP server, which makes the documentation API reference available. And then finally, of course, also the CLI can be invoked by Cursor, which is extremely important to validate that the implementations are actually correct. Here's a flowchart that just shows, okay, what does the agent actually do as it's trying to autonomously build these features? And I'm not going to go through all the details, but it looks at the rules, looks at the different MCP tools, and then does its first shot implementation, and then validates it and fixes any issues that it finds. And that's exactly what we saw in the live demo earlier. And now let's take a look at a couple of my favorite lessons that I've learned building the system. One is just how extremely important it is for these LLMs to have a verification mechanism, because an LLM will almost never get things right immediately. And they need a feedback loop, a mechanism where they are told if they're doing something wrong, that they've done it wrong, and what the error is. And that feedback mechanism, in the simplest way, is a human who actually looks at their output and tells them this is dumb, this is bad, and this is how you fix it. But of course, that requires a human to be in the loop, and it's much better, much more efficient if you can actually have the system itself provide a trusted, formal verification mechanism and validation errors. You've seen it with Tecton, that's Tecton Plan. It verifies a lot of the feature definitions, and then the next layer of testing and unit tests. And then the final layer of testing, which I didn't show here, would be integration tests. But besides testing, what's also quite important is that agents, they actually are really, really good at highlighting user experience gaps. Whenever I see the agent hallucinate something, it's oftentimes for somewhat good reasons. Like, you could imagine a human hallucinating those problems too, and making up parameter names, class names that don't exist, or importing them from the wrong module. And it's oftentimes a coin flip where I'd say, actually, the agent should have known better versus no, actually our developer experience could be improved here. And this generally leads me to believe that the new developer experience is really agent experience. And this will become much, much more important, especially for developers of developing developer tooling like SDKs, APIs, etc. Those will be built and documented in a way that will be particularly easy for an agent to process and understand. And there's a lot of overlap here, but there's also differences. Like a human cares about good fonts, beautiful images, progressive disclosure of complexity, etc. But agents, they care about good examples, very structured examples, and they're extremely easily thrown off by minor mistakes. Another really cool learning that I've had building the system is that agents get to pre-train on your public documentation, even your public SDKs. And our SDK code has always been on GitHub. Our documentation has been public for years. And every single foundation model out there is pre-trained on Tecton and has an intuitive understanding for what Tecton looks like. But this pre-training is also an issue because, of course, Tecton doesn't stand still. And some models out there, I think 4.0 is cut off somewhere in 2023 or 24, I don't know exactly. And if I don't give it additional information about what Tecton looks like today, it's stuck in the past, and it tries to build features using an ancient version that doesn't make sense anymore, and it requires quite some nuance, if you will, to teach the agent about how to use the latest version. And you need to leverage things like the MCP tool, good cursor rules, and then also good validation errors if it's really stuck in the past and tries to still use an old version, basically, of Tecton. Here's an example that I'd run into, which I loved, where the agent was dreaming up the usage of filtered source. It's a class that we deprecated years ago, and I was really surprised why it still tried to use it. And oftentimes you can just ask the agent, actually, hey, why did you do what you did? And it's not always telling you exactly the truth, but you can get some good insights. And here, in this specific case, the agent told me that it's gotten the information about using the filtered source from the SDK reference. And I was confused by that because the class didn't exist anymore. And then when I dug deeper, I realized that that class name was still mentioned in doc strings. And so we had to clean it up, and it's working much better since then. The next lesson is that I've seen, as I've been building the system, that I can get away with fewer and fewer cursor rules, which are really Cursor's way of doing prompt engineering. And as I've gone through the different models, I was able to drastically reduce the cursor rules. And then separately, it's just really fascinating actually how much better these models are getting. Like initially, Sonnet 3.5 was great, and then I got really blown away by Gemini 2.5, and now actually OpenAI's O3 is pretty promising too. And then also one thing that I loved seeing was just how, given that Tecton is a declarative interface and everything is written as code, this is ideal for LLMs because they're trained on a ton of code, so they're really good at writing code. And if you have a system that is declaratively configured, whether it's declaratively configured using things like SQL or Terraform or YAML or anything like that, those are always great setups for these LLMs to hit the ground running pretty quickly at writing code for your tool. And then last but not least, what I really, really, really want this year is a way to run evaluations. Because as you change the MCP tools, as you change the cursor rules and whatnot, what you really want to know is, hey, did I now overfit on this most recent example, or did I make generally things better? And really the only reliable way to do that is to run evaluations. And running evaluations is pretty doable if you just have a simple LLM and a prompt and one response. But in the world of agents, where you can have control loops, especially if you have an agent within Cursor, there's just no framework yet to test these things automatically. Thanks so much for watching today's webinar. I hope that after seeing all these demos and looking at these lessons learned, you're as convinced as I am that the seismic shift that we're seeing in the art and discipline of software engineering, where software engineers are getting significantly more productive with AI-assisted coding, is definitely also going to massively influence the discipline of building and deploying machine learning applications for use cases like fraud detection, account takeover detection, or insurance underwriting. And I think what's cool here is that machine learning engineers aren't just going to get 10 times more productive than ever before. I'm sure that's going to happen. But I'm also really optimistic that beyond that, we're also going to see that the barrier of entry really is going to fall dramatically, where in the not too distant future, we'll see that folks who maybe have just a computer science degree or fresh out of college are going to be able to pretty quickly pick up these tools to build real-time machine learning applications in the matter of a couple of days or maybe weeks, and put them into production. Because generally, when I look out at the world and the different use cases that enterprises are running every day, we haven't really even scratched the surface yet, and how much more impact machine learning can really have on the world. Maybe we're 1 or 2% of the way there. There's still way too much stuff happening with handwritten rules or batch machine learning applications or whatever it is. And I'm convinced that we're going to see a drastic acceleration in the application of real-time machine learning for these types of use cases. And if any one of you wants to chat more, swap some notes, discuss anything that I touched on in this webinar, please always feel free to reach out to me directly. I'm at kevin@tecton.ai. And yeah, with that, thanks again so much for watching, and enjoy the rest of your day.